So Tim and I did a talk last year about Spark on Mesos and why it's interesting and all that, and this is sort of an update to what's happened in the last year and where we see this going. Let's start with a little intro. So I'm Dean Wampler. I sort of figure out what we should do with big data at Lightbend. Lightbend's the company behind Scala, Akka, and Play. We're partnered with Mesosphere to provide Spark and Akka on the Infinity stack, which is Akka, Play, Scala, Kafka, Cassandra, all in Mesos. And we'll talk a little bit about that later as an option. But I've been doing this stuff for a little while, big data, written some books for O'Reilly, and I'm very passionate about Scala as a big data tool.
Yeah, I'm Tim. Worked at Mesosphere before, and I'm an Apache Mesos PMC. I also worked on Drill as a PMC. I help maintain Spark on Mesos.
Okay, so we're going to talk about, just briefly, why Spark on Mesos, why it's an interesting option. Again, what has happened since the last year. Tim put together a buzzword-filled demo that I think you'll like. It's really awesome. And then talk about what's coming. So just briefly, why Spark on Mesos? Well, Hadoop is really great. It's very mature. It's fantastic for very rich, diverse data environments. But there are some limitations. Yarn is not particularly great if you want to run all of your stuff on one cluster. It's really designed more for, I'm going to own the cluster for Hadoop-like stuff, but if you want to run like all of your web servers and your databases and stuff, it's really not the right tool for that. So the ability to run everything on giant clusters is a nice advantage of Mesos, and that's one reason we really like Spark on Mesos at Lightbend. The other thing that's happening is we're moving more towards streaming architectures. Kafka is like the new hotness, and Hadoop is adapting to satisfy the kinds of workflows and job requirements you need for streaming, but in some cases it's not quite as dynamic as it could be as streams go up and down in scope of how much they're processing, the kind of resources they need, and so forth. So something that's more dynamic, like Mesos is a really nice option. I sort of alluded to this already. There's this sort of emerging stack that goes by this kind of nasty, awful acronym, SMAC. Spark, Mesos, Akka, Cassandra, and Kafka. And so, if you really love Cassandra, it's hard to use that with Mesos. All right, so let's talk about what's happened since last year, and Tim will start with what's new in Mesos.
So before we talk about Mesos, just a show of hand, who here uses Mesos? Either in testing, production, somewhere? Okay, cool. Who here uses Spark on Mesos? Wow, this is definitely more than last year. Well. From what I can tell, at least, from all the bright lights and everything. All right, so what's new in Mesos? So since last year, we worked a lot hard on Mesos. There's a bunch of stuff that happened. I'm just really going to highlight a few stuff I feel like that's going to be interesting for all of you, and also very related to Spark. So first thing I want to mention is maintenance primitives. You guys maybe never heard it too much, but maintenance primitives is very important for people running large-scale clusters. Right, how do I update this rack at a time? How do I update nodes at a time? Right, I need to be able to coordinate which frameworks goes down, which nodes need to be drained. So cluster managers these days are starting to build these primitives because we're ready to really operate things at larger scale. So Twitter uses it, and a lot of larger cluster operators are all starting to use maintenance primitives. And the second thing we really do a lot is trying to bring multi-tenancy story better support for Mesos. So resource quotas, dynamic reservations, all these primitives are simply able to tell that if I'm the user and I have multiple teams and multiple organizations in a company want to share a same cluster, either as frameworks or even the same framework. Maybe I have a Spark team that runs in two different places. How do I make sure there's enough resources for each team? How do I make sure there's enough resources for my QA team, for my data science teams, running all Spark frameworks and Mesos? So quotas is a great way to limit and also to ensure there's that amount of resources available for you. And dynamic reservation simply means that in the past, we only are able for you to reserve resources statically. So when you launch an agent, or we call it a slave before, an agent, you can actually reserve a certain amount of resources per agent. But now you can dynamically, at runtime, change that reservation. So it becomes a much more fluid and dynamic environment for you. Some of the features I want to highlight that it's already shipped, but it's not currently production ready yet. But it's very interesting is we have a lot more container runtime support now. So CNI is a new container network interface that comes from CoreOS. It's supported in Kubernetes as well. So if you want to use some overlay network in your cluster, maybe have a Spark job that's running on Docker containers that wants to connect to some other Kafka container, but they also don't expose like network natively on a host network, you can use bridge network, but then also join an overlay network on top of each other. So CNI network supports, GPU support, so GPU as a first-class resource supported on Mesos. I'll show you how that works later on. I think the most interesting part, what I actually worked on, is unified containerizer. And you probably don't know what the heck that means, but it simply means that you can run all those different image formats through Mesos. And because we had Docker supports into Mesos before, but we're simply just telling Docker daemon to launch all our containers. And we saw a different bunch of issues. So what we did in the last year was working on what we call unified containerizer, where the cool part is you can run Docker containers without Docker. No Docker installed on daemon on your agents or anywhere. You can point to a Docker registry, say, go and run my Spark image. It will download, it will run it through our own Mesos containerizer. And if you have more questions on why we did that, there's not enough time to explain all the motivations, but this is one of the most key parts to make containers much more production ready for all our users on larger scale. What also happened since last year is that it's not just Mesos, the key component itself has been improving. The whole community has there's a lot of busy activity happening in the community. One of the things is called DCOS. Mesosphere open sourced something called Data Center Operating System. We used to offer this as a product, but now this is all open source for you. Because Mesos, if you tried it before, you cannot just take Mesos and run it, right? You need a framework. And once you have a framework, you need service discovery, you need a bunch of tools that's around it. How do I package and install something really quickly? So DCOS is just a suite of components, a suite of tools ready for you to use as this big stack, and it's all open source, and there's a lot of activity going on. And you get a nice little UI like this. If I want to use Kafka, I use the SMAC stack, for example, I don't have to go and figure out how do I find them or how to operate them. Each one of these has a scheduler that we are dedicated and working on to making sure that it's available, highly available, and ready for production. So we can literally click on install Spark, literally click on install Kafka, and you have a CLI dedicated for each one of them, so you can operate and operate each one of them.
Okay, so excuse me, what's new in Spark on Mesos? By the way, I think you should really just use DCOS open source, not just go bare Kafka at this point, but that's just me. So a couple of things have happened in the last year. One is that we worked on an integration test suite with Mesosphere, and I'll explain why that's a big deal in a second. A rewritten scheduler to try to improve how Spark and Mesos interact. Mesos framework authentication, so that sort of completing the security story that you need to have. And cluster mode now supports Python, not just Scala. So the integration test suite, what kicked this initiative off was there was a milestone, a release candidate build for Spark. I think it was like 1.5 or 1.6, I forget which one, that just absolutely broke Mesos right off the bat. I mean, it was completely broken. It didn't work at all. And it was clear that it was because we, as a community, hadn't done a good enough job building an integration test suite for Spark and Mesos. So Lightbend and Mesosphere got together and wrote one. It's not complete by any means, but it was our attempt to build something that could be run in an automated way, in the usual way, to verify that all the core primitives still work with any build. And here's the GitHub link if you want to take a look at it. Also, just a few details about it. There's a nice little convenient sub-package for actually building a Dockerized version of Mesos. You can actually run this on your laptop. It's one of many ways that you could run Mesos in this case. And then the actual test code is in this test runner sub-project, which attempts to exercise some of the features. A few of these that are listed here we'll get into in just a minute. Although if you like to contribute to open source, there's actually some areas where this needs to be filled in. We also implemented a new coarse-grained scheduler. I'll let Tim go for that.
Cool. So, okay, another show of hands. So for those of you who run Spark on Mesos, who actually here runs the fine-grained mode? Who actually, okay, here's just a few left alone folks here. Okay, so I assume everyone else runs on coarse-grained mode. So I'm not going to explain fine-grained coarse-grained mode because we did that last year. But I'm going to quickly tell you how coarse-grained scheduler works and why we did a new one. Right? The old coarse-grained scheduler basically, really simply, takes all the offers that comes from the master and tries to meet the minimum CPU and memory requirements for your Spark executor. So if it at least has one CPU and probably has 2 gig of memory, I can launch a Spark executor there. And all it does is trying to run one Spark executor per agent, and that's it. And until you have enough cores so we can, the sum of the cores you launched so far meets the spark.cores.max. If it doesn't meet it, it'll just keep trying to launch more and more. So that's really simple. But what was the problem? Why do we have to write a new one? It's simply that, right? So let's go back to the example. If you have 3 agents, right? It's totally empty, 8 CPUs, 8 gig of memory each, right? And I have 2 settings here. Spark cores.max equals 12 means I want to allocate the maximum total number of 12 cores for my whole Spark job. Right, every executor should have roughly 4 gig of memory. I'm ignoring all the overhead and all this stuff you had to just assume it's just 4 gig of memory totally we want to allocate. Right, and what happens? Well, we'll pick the 2 offers. We'll launch one big executor. Right, we have 8 cores we can totally use from this offer from this agent, and we'll launch a 4 gig memory Spark executor agent 1. Agent 2 only needs 4 more because we specified 12, right? So we just launched the second executor. So now the sum of the cores is 12, and we're happy, right? So if we imagine, we're not always an empty cluster, right? There's always things coming and going. There's multiple frameworks running. There's multiple Spark jobs running. So you never really know what you're getting. If you're getting a smaller, skewed sort of offers coming in, right? What happens here is we just basically have a totally very different allocation here. We have maybe one big Spark executor, but 2 little tinier Spark executors, right? Because all we did is try to make sure it meets the minimum CPU requirement per Spark executor. So this is sometimes a problem for your users. Like every time I run coarse grain mode on Mesos, I get various type of performance. It depends on what kind of workload I'm running. Sometimes it's faster, sometimes slower. We never really know what the CPU allocation is like. And this is because we simply just take what we got from the offer, and we didn't do too much intelligence on top of that. Another problem we also saw from a community, actually, is that because we only allow 1 executor per agent, if I have a really big box that has 64 gig of memory, then I can only launch 1 executor per box. And this becomes a problem because I don't want to really necessarily have one big giant JVM with 64 gig of memory allocated to it. You know, my GC pauses becomes terrible. You know, I want to have a more finer grained control, maybe split into 2 instead of one big JVM running one big Spark executor. So our users can't really specify that. So basically the problem comes down to we're a little bit limited. We only launched 1 executor per slave. It's sort of an unpredictable performance. You don't know how many cores you're getting per executor, which means every executor will have a very different, not all the time, but it can seems like a very obvious difference of performance. And you can skew your allocation. So when you have maybe not a CPU IO-bound workload, maybe I do have a really large Spark streaming job, and I have a very large allocation in one box, and it's tiny ones in the other boxes, I might be really over-allocating the network resources, which we don't really have a way yet to specify that in the Mesos, from the Mesos point of view. So what do? We simply just make it more predictable, where we just want to say, instead of just having all kinds of cores showing up for each executor, at least tell me I can have 4 cores per executor minimum. I need at least 4 cores to launch the executor. And instead of only launching 1, I can launch multiple of them. So this is definitely better than having just all kinds of CPU and memory showing up per executor. You're getting a more predictable performance each executor that you're getting at. So the only last part that we didn't have any attacks on is how do you solve the skew problem, right? In this example, we're still having a 2-to-1 sort of skew. So this is next, though. We haven't worked on it yet. Is depending on what kind of workloads and what kind of jobs you're running, you might want different kinds of strategy. How do you want to spread it across? Do you want to bin pack them, or various kinds of ways to spread your containers around? And this is the power of Mesos, where it's all on the scheduler side. Because we're 2-level scheduling, we can do very simply on the Spark scheduler side to do a very Spark specific allocation.
Okay, so just one slide on this. So Mesos allows frameworks, and frameworks is like the Mesos term for the applications, the connector that hooks your, like Cassandra or whatever, to Mesos. And oftentimes you want to use role-based authentication and all these sorts of things. Well, now there's been more enhancements to support Mesos roles per framework and to integrate that with the rest of of Spark and so forth, so that you're getting to a better story about security, authentication and authorization and that kind of stuff. Mesosphere has also been working on integrating Kerberos with Spark, for example. So one of the reasons we ask about fine-grained versus coarse-grained mode is there's a debate in the Spark community about whether we should deprecate and eliminate fine-grained mode. This diagram illustrates really what's different about them. The main difference with fine-grained mode versus coarse-grained is that there's really, in fine-grained mode, just one Spark executor per task instead of having a Spark executor inside a Mesos executor that owns all the tasks inside that Mesos executor. Now, the advantage is you get more fine-grained resource allocation. You're not holding on to resources in fine-grained mode that you would be holding on to but maybe not using in coarse-grained mode. But it also means that there's more startup time because you're starting up more stuff for each task with fine-grained mode. So these are the sort of trade-offs that led to the emergence of these two modes. So, for example, you might use coarse-grained mode when you're running interactive queries where you want the query to run more quickly because you don't want your train of thought to be broken, and you don't mind for the 10 minutes, hour, whatever that you're working that you're actually just holding on to resources and maybe not just constantly using them. But when you're running like a long-running streaming job, for example, where at 5 p.m. There's always a peak in traffic every day, and by midnight it's dropped to a bare minimum, you really don't want to be holding on to all those resources when you don't need them. And we had this problem of having one executor for coarse-grained mode per worker node, and that also made it inconvenient to actually be limited to just coarse-grained mode. But we've kind of gotten rid of some of these advantages of coarse-grained, or rather the need for fine-grained mode. Like we can now run multiple executors on each node. Dynamic allocation is the idea that we can just simply reclaim executors that are being unused. And then if they are needed later, then the whole allocation process will provide the needs. So if you have a streaming job, if it's, the load is dropping off, then some of these executors can be reclaimed. And unfortunately, when you look at the source code, there's really like two parallel implementations that overlap considerably. I actually spent a weekend once trying to extract like a common superclass, and I basically gave up because I wasn't convinced I was actually making things better. Maybe it's because I'm an idiot programmer, I don't know. But we kind of realized that we had this problem of maintaining two things. Maybe it wasn't really all that important to have fine-grained mode if we could eliminate the advantages of having it. And so technically fine-grained mode is now deprecated, but we're not quite able to remove it yet. So we need feedback from the community, but hopefully we can eventually have one grain mode, so to speak, that meets everyone's needs. And now I'll let Tim do the amazing demo that I told you we were going to see.
All right, let's do a quick demo. So I've been thinking, how do I put as much buzzwords as I can in one sentence? So here for all the underlines. So okay, what are we doing here? We're going to run deep learning, right? Of course, this is the hottest thing on Earth right now. On TensorFlow, with Spark on top of, Mesos, using GPUs in the cloud. Let's do it. All right. And the success ratio, I have no idea. But so let's see. So what I want to show you, actually, it disappeared for me. I want to show you what I did. So Spark, TensorFlow, there's already a blog, right, from Tim Hunter about running TensorFlow on Spark. So I really just took the same example, right? I took the notebook that was available. You guys probably already seen this blog post. It seems like it's pretty popular. I took the distributed processing images using TensorFlow. So for you guys who didn't know what this is about, this is basically taking a pre-trained model, right, a neural network model, and downloading a bunch of images and just finding out what's in that model, what's in that image. So like you take an image like this one, and it'll give you a probabilities what's inside this image. So to run this exact same example on Mesos, what's the benefits of that, right? If you run a big cluster and you own every resources and it's just running one job for one team, that's fine, right? You own every GPU. Some other team member is using your GPU. Like I'll just wait for him to finish. But when you run a lot of frameworks, when you run a lot of different jobs at the same time in your cluster, GPU becomes a resource that needs to be isolated and needs to be managed, right? Just like any CPU or any resources out there. So once we added GPU as a first-class citizen resource into Mesos, means it's going to be offered, GPU will be offered as a resource to the frameworks. If your framework wants to use a GPU, and of course this is really beta, there's a lot of things that we haven't really implemented, but if I just want to use GPU in Mesos framework, I can simply use it as a Scala resource for now. All right, so let me see if I can show a bigger screen here. Okay, so let me show you how it works. So I'll just start, I'll start a master, and I'll start a slave. But in this case, what the agent looks like, if you can see this on the screen, I added what they called isolation GPU NVIDIA. So we did initial work with NVIDIA, partnered with them, to able to auto-discover GPU devices on the host and automatically make it a resource available for the frameworks to use them. So if you specify isolation equals GPU NVIDIA and start this agent, let's see, start agent. Okay, so now it's running. We're just gonna run. We're gonna run Spark on using. So I took the whole distributed processing images into just one big Python file, basically. So instead of running a notebook, it's just easier to run it here. And I'll just run PySpark. And so if I run, since I don't have too much time, I was originally going to show two different modes of running it. So what I did in the Spark framework side is turn GPU enable on and off. If you turn GPU enable to false, that means it will not able to discover any GPUs on the devices, even though it's on the host. We automatically disable all access to it. And if you use that GPU device from your framework, that framework's task is the only one that is able to see that GPU and automatically discover and use that GPU. So just for time's sake, I'll just turn it on to be enabled and just run our Spark job here. So I'll just run the demo. It will run just a TensorFlow, the same exact demo we used on that blog post. What I want to do is show you that what's happening in the background. So TensorFlow will start up, and it will automatically find out that there is a GPU device on the node. It's actually still running. Here it is. Right, you can see that on the left-hand side. It did found a GPU. Yeah, it did found a GPU here, and automatically assigns it to it. So what I won't do is, at Mesos client did this demo, is this, I turn that flag off, then TensorFlow will automatically say there's no GPU devices available. Just map all the CPU devices and use that. And then you get back the same results you've probably seen as a demo, a picture and the predictions and stuff like that. So I think adding more accelerators devices, that's basically a demo. Just for the sake of time, they didn't do the whole thing, but.
Nothing like looking at log files, huh?
That's the future.
Yeah, that's the future.
People getting rid of GUIs everywhere. Anyway, yeah. So I think allowing GPUs to be isolated, and we're going to be doing more work with GPUs. So we're going to actually expose device information, what kind of GPU and memory is there, and also topology information, which is very important when you're running multiple GPUs across different devices. And is there NVLink available? Is there certain hardware features that's available on these GPUs? And that will be all available through a Mesos framework. So if you're a framework that wants to use GPUs and wants to be using them for multi-tenancy story, I think something with Mesos can definitely help out a lot in that case. All right, so what's next for Mesos? We're going to keep on working on GPU support, unified containerizer. We're going to adding pod supports. If you guys heard of Kubernetes, that's a very big thing for them. We're going to natively support pods. We're going to do a bunch of support for there. There's multiple roles, so every framework can register itself as multiple roles. So this helps a lot of different multi-tenant story we're looking at. A better container security, a better event bus. All these things will help the framework developers to be notified what's happening and actually help secure different containers that are running on the same node. So you can make sure that he never changes the host name, for example, or doesn't do any crazy stuff on the host. So better container security definitely helps a lot, even from between containers.
So on Spark, we're going to integrate the GPU support. Like, he was using it, but it's not actually part of any release of Spark. We'd also like to be able to use revocable resources, which is the Mesos feature, where you can be given resources optimistically, but then they can be taken from you if you for higher priority usage. Always continually trying to improve scheduling. He pointed out some issues that we had with that we've addressed, and making the integration tests more robust and more full-featured, so that we never see problems. And I think in general, production always needs to be easier, like better access to the logs, more information in the UIs, improved metrics. This is a lot of stuff I've been thinking about how we can improve in general, so that just the whole production experience is better. And that's it. Thank you.
Excellent. Do we have any questions? Over there.
Here. Maybe.
Hi, you talked about multi-tenancy and resource allocation from a CPU and memory perspective. Are you doing something for I/O throttling?
I/O throttling. Treating I/O as a resource.
We do have block I/O as a resource. Already have. There's a patch for that. We haven't really put it into release yet. But yeah, I think there's also various kinds of things that are happening in the community. But block I/O is the first thing. If you have other ones you want to discuss with us, we'd definitely love to discuss more. Yeah.
Hi, I had a question with multiple executors per slave. So like right now with Mesos, we read the log files a lot for individual executors that are in each slave. So is that going to change in the UI at all? Like how are you going to target which executor if you have multiple ones running on the same machine?
So are you talking about the Mesos UI?
Yeah, the Mesos UI.
Yeah, so at Mesos UI, you'll see multiple tasks then, right? Every task is an executor. So you'll see multiple tasks, and each one is a different executor. And then you can then click on each one of that, and it will show you the agent ID number next to it. So you'll see it. And we're actually trying to improve the whole experience. We're trying to make a Spark UI automatically link to all these logs, so you don't have to go through a Mesos UI and do those cuts and stuff. So yeah, look forward to that.
All right, are there any other questions? Anybody?
Hi. Can you talk a little bit more about, you talked about the feature of pushing down the quotes and management of multiple resources between different tenants. Can you give a little bit more details how it works and what are available there?
Can you repeat your question again? Can't really hear you too well.
You mentioned about pushing down to the Mesos, from what I remember, didn't work with the latest version, but previously didn't have much ability to kind of limit certain resources and give quotas and all this stuff, right?
Yeah.
So you said that's something what is coming, or it's already?
Oh yeah, quotas.
Can you give a little bit more information on this one? What is there?
Yeah, so the latest release of Mesos already have quota supported. So there's an operator endpoint for you to go to the master, saying for this role, I want to ensure there's maybe at least 20% of my resources available for this particular role. And so any other roles will not be able to use that resources. So you can use endpoints, talk as REST endpoints to say add more quotas, remove quotas, and change and do things like that. So just one way to ensure there's enough resources per role. Yeah. If you have. No. So Mesos will not even offer that much resources to your role or the other roles. If there's a dedicated role, 20% for that role, only 80% will be allocated to different other roles. So we guarantee that, basically. There's no way we can overcommit, basically. And our isolation will make sure if we overcommit anything, we'll just,
I see.
Would you be able to articulate really the key benefit of using container Docker approach to, because a while ago you kind of brushed on it, but didn't really elaborate.
Why unified containers?
Yes.
Yeah, so the biggest problem for us is if you run Docker containers using the Docker daemon, they own the whole container run path. Basically, I tell Docker run a container, they control everything. So we have a lot of things that we've done on the Mesos containerizer side, like isolators, for example, GPU supports, persistent volume supports. And all these things are isolators to the Mesos containerizer. So we can't run those code from the Docker daemon point of view. The Docker daemon only allows volume plugins, network plugins, and these are really fixed points where their flexibility is only to certain points. But we need much, much more finer grain. We're working on nested containers, we're working on very different isolation. So the only way to compose on top of it really isn't really, we need to own the whole path. And we heard also some usability, stability concerns from Docker daemon running on our scale and Apple and somewhere else's. And so we know Mesos containerizer scales. It has been running on scale for Twitter, for all these places for a long time. We want to reuse those code and make sure it runs for everybody else with Docker containers. Yeah.
All right, excellent. I see a few more questions, but we have run out of time. Can we do those offline? Let's give our speakers one more round of applause.